Great. Hello, my name is John Byrne, and welcome again to maybe the third out of the three videos on the ideal gas equation. We're just looking at some formulas. So this is to do with ideal gas. You'll see in previous videos where we're looking at pressure, volume, and temperature of a gas. Ideal gas, we measure pressure in pascals, volume in meters cubed. Temperature in Kelvin, not in degrees Celsius. We have to convert it. We do so by taking the temperature in degrees Celsius and adding 273. 100 degrees Celsius in Kelvin would be 100 plus the 273. That comes out to be 373. And so the temperature in Kelvin for boiling, pure boiling water would be 373 Kelvin. All right, so that's how you do that. When we look at individual laws, how pressure and volume and temperature and pressure and temperature are related, then we find these come together and we get this relationship, PV over T is a constant. And what we can find out, we've seen in previous videos that that ratio remains constant. So you can work out if there's a change in any of these, the ratio stays the same, so you can work out any of the unknown factors, variables, and then also that constant is equal to N times R, the number of moles times the molar gas constant. Or in this case, we're going to look at N times K, and we're going to have a look at this formula. All right, and what those variables mean. So that's what we're looking at today. So this is to do with, we might say, where we're talking about particles, maybe a number of atoms, or possibly number of molecules. Okay, so maybe it would be atoms if it was a noble gas like helium, neon, that kind of thing. But if it's a particle like nitrogen, oxygen, you know, they don't exist on their own, so we're looking at a number of molecules in that sense. So that's what we're looking at. And so the formula is PV equals capital N KT. So yeah, capital N, lowercase t, and lowercase k and t. T, as always, is in Kelvin. Don't forget that. What do these mean? So N equals number of molecules or number of particles. So I'm probably going to look at just use the term molecules. But remember, it could be particles, so it could be either molecules or atoms. Okay, and then what's key? What's key? What's K? K is something called Boltzmann's constant. Again, a fixed number. Okay, and you'll be told this in the question. I believe it's 1.38 times 10 to the minus 23. Okay, and that number is probably joules per Kelvin, I reckon. That's what I reckon that might be in, joules per Kelvin. Might be wrong, but anyway, that's the number you'll be told in the question. All right, so again, let's just have a look at rearranging. So that's the general formula you'll be given in Unit 5. And how do we rearrange it? So let's have a look. Maybe we want to make pressure work that out, work out what the pressure is given the volume, number of molecules, and the temperature in Kelvin. How do we do that? So we start off with P equals NkT. All right, we want to make pressure the subject, so what do? We're going to divide both sides. Those two multiply together. To get rid of it, we divide by V, so it cancels. It'll cancel on this side, so just leaving P. But if I've divided this side by V, I have to divide this side by V as well. So it becomes N times K times T divided by V. You simply multiply the number of molecules by Boltzmann's constant times the temperature in Kelvin, and then divide by the volume in meters cubed, and that tells you the pressure in pascals. Okay, what if you want to work out the volume? What if you're told the pressure of the gas, the number of molecules, and the temperature in Kelvin? Well, similar story, except instead of dividing by V, this time to get V on its own, we have to divide by P. So the right hand side, the top bit stays the same, and then the P cancels on this side, but we have to divide by P on this side. Make that a little bit bigger. There we are. And so same again, we just multiply those three things together, divide by P. Okay, what else could we do? We might be asked to work out the temperature, being told the others. So let's start again. PV equals NkT. Okay, so I might like to have the unknown thing on the left hand side, so I'm just swapping these two things over. they still equal each other. To get T on its own, I can do it all in one go. I can divide, these three things are multiplied, so I do the opposite to get rid of them. N and K are multiplied by T, so I'm going to divide both sides by NK. That leaves T on its own, the PV stays where it is, and I just get N times K. N times K on the bottom. So to work out the temperature in Kelvin, I multiply the pressure by the volume, and then divide it by the number of molecules or number of particles times Boltzmann's constant. Boltzmann's constant up here. Okay, might want to put brackets around that if you haven't got a fraction key. That's how you work out the temperature. And to be honest, Boltzmann's constant stays the same. That ain't going to go anywhere. But the only last thing you might be asked to work out is what is the number of particles, number of molecules, if you're told these are the factors. Let's have a look at that then. So again, lastly, we start off with the formula that will be given in the question. We want to make N the subject. I'm going to put the unknown things on the left-hand side. Okay, to get N on its own, well, these are multiplied, so I divide by K times T. It will cancel on this side, and it will appear underneath here because we're dividing both sides. So if I divide this side by KT, it cancels to leave N, and then this one, the KT, I'm divided by KT, so I have to divide this side by KT. Alright, so to work out the number of molecules, I need to multiply the pressure in pascals, or newtons per meter squared, by the volume in meters cubed, and then divide it by Boltzmann's constant times the temperature in Kelvin. Okay, and again, if you haven't got a fraction key, you might, when you hit divide, you want to maybe put brackets around those things. Okay, there are variations of using this form of the ideal gas equation. All right, best of luck with it all.